Hello again, algebra students. Welcome to part 2, chapters 2.6. Hopefully we can keep this into one video tonight. That's what I'm hoping happens here. If you're at this point in the class, if you've done all the videos and the work today in class, you've learned a little bit about this thing called unit analysis. And I want you to see in these next two problems how we can use unit analysis to solve a question like what's in front of you right now. In this particular example, we are pretending we have something happening where we have this measure of 2 quarts per minute. Maybe it's the rate at which a bathtub is draining or the rate at which a bathtub is filling. We don't know. We can put context to it later. But they're asking us to convert it to this rate of gallons per second. Okay, well, we're going to use the same idea of what we did today in class and in the last video. And if you missed that, you need to go watch the last video about unit analysis and how we use the unit labels to solve and make a conversion. So we're going to start out the exact same way we did before. We're going to put 2 quarts. Now this is quarts per. Remember, that means per. Quarts per minute. But I want you to write the fraction like this. It's per 1 minute. And you have to put the label in the denominator now, since we now have a label in the denominator. Notice they're asking us to make a conversion change of the capacity as well as the time. So when we're all done with this, we need to have gallons at the top and seconds in the bottom. Okay, so that's what's happening. We're actually doing 2 conversions here. So let's just focus on the quarts first. Okay, and we're going to basically do the same thing we did in the last video. In the last video, the first thing that we want you to do is identify what this label is and match it right there. Okay, we want to change the quarts to gallons. So what I'm looking for now is a conversion factor of quarts and hopefully to gallons. Now, you should have this from class today. And if you look right here, see if I can show you, get it on the screen, 4 quarts equals 1 gallon under liquid capacity. Okay, so I know that 4 quarts is equal to 1 gallon. So I do have a conversion that I can do quarts is equal to gallons, because remember that this factor they have to be equal units. Okay, 4 quarts is the same as 1 gallon. So if those are equal, that's really just the number 1. And that's how we're using the unit conversion, where we have the units here. And the reason we picked that is because we want to cancel these quarts when we multiply. And we do. So now I'm left with gallons in the numerator. Okay, so that means I have now established this unit as the capacity unit in this problem. But the problem is I have gallons, but right now I have gallons per minute. If I were to multiply this out, which would be 2 over 4 or 1/2, it would be 2 gallons per 4 for 4 minutes. But I don't want minutes, I want seconds. So I have to do another multiplication problem. Now let's think about this. I currently have minutes in the denominator. I want to get rid of that. So if I get rid of that, where does minutes need to be when I multiply this? What's going to make that cancel? It's currently in the denominator. I have to have minutes here, because that will now cancel out. So if I have minutes here, okay, well, I'd like to have seconds here if I have a conversion factor of minutes and seconds. Do I? Yes, we do. We know that 1 minute is equal to 60 seconds. So again, that represents the number 1. Now, look what happened. This minute canceled out that minute right there. So if I multiply straight across I can reduce this 2 and the 4 here. That'd probably be easier. I'll tell you what, I'll change color to do that. 2 goes into 2 once, 2 goes into 4 twice. Now if I multiply 1 times 1 times 1, I get 1. What's my unit there? Gallons per 6 times 2, 120 seconds. So that's the answer to that question. 2 quarts per minute is the same thing as 1 gallon per 120 seconds. And there it is. Okay, easy. If you use the units to do that. So please take time to learn that. Let's do another one real quick here, and then see if we can get the last problem and wrap this up. It's going to be close. I think we can do this in one video. Let's try. So this problem says you have 75 cents per hour. I don't know what that's for. That's not very much. Who knows? At this point, we don't care. We're just learning how to make the conversion from cents per hour to dollars per day. Okay, so you write it down. 75 cents. Don't write it as a decimal because we're using the unit of cents. So that's implying the decimal value there. Per 1 hour. All right, so we're going to multiply. Now we have to get it to dollars. So let's deal with the dollars first. Well, if I want to cancel cents, I start by matching the label. Always start by matching that label. It has to be the first one you do. You have to get rid of it. But do I know how many cents make a dollar? Well, I should. Okay, I should know that 100 cents makes $1. All right, so guess what? We've got the unit there that we need as the numerator, but I have hours, so to get rid of hours, okay, what has to go up here, right? Because I want that to cancel that. So do I know how many hours are in a day? Because I want to turn it into days. Yep, I know that 24 hours is equal to 1 day. Right? Now, that cancels out that, and there's my denominator unit. So here you've got dollars per day. Right, you see how that works? Now, if you multiply 75 times 1 times 24, you could reduce some factors here, but this one actually works out pretty simple if you just multiply across. That works out to be 1,800. You can double check me. 100 times 1 times 1, I'm pretty sure that's 100. And again, the 1,800 is dollars, and the 100 is day. Okay, reduce that out. That divides out like this, and you end up with $18 per 1 day. And there it is, $18 per day. All right, and we are happy. All right, we are at 7:42. We're gonna go for it. Let's see if we can wrap this thing up in one video here. We'll probably press right up to 10 minutes. Just 2 minutes to do this question, so here we go. Unit rate. You will need to know how to find the unit rate of something and what it means to us. All right, this says find the unit rate of each store. And then which store has the best deal? We are making the assumption that on this deal, all the shirts are the exact same quality. That has nothing to do with this. Store A sells their shirts $25 per 2 shirts. See the connection there with what we've just done? To find the unit rate, all you have to do is divide that. Because when you divide that, it basically figures out how much per one, whatever the denominator is. So $25 per 2 shirts, basically you divide that out and you end up with $12.50 per 1 shirt. So the unit rate for store A is $12.50. Okay? All right, well, let's take a look at store B. We do the same thing. We got $45 as our numerator per 4 shirts. Okay, so divide it. Just grab your calculator and divide it out. 45 divided by 4. Let me show you something just because I can and it's cool. I can do this. 45 divided by 4. $11.25. All right, sweet. Let me get my pen back. Whoops, there we go. $11.25. And then the last one. 30 for 3. I think we could all probably do that one in our head. $30 for 3. That's $10 per shirt. Okay, so all of these things that we found, these are unit rates because it's how many for 1 shirt. Best deal is this one right here. Again, we're not assuming anything other than the price. So the unit rate is used to figure out what your best deal is or how efficient you're using something per something. We made it 10 minutes and 12 seconds, so we're done. See you tomorrow.